Hi guys, got a little test to do here with my copper and magnesium strips for a battery, suggested by Tellboy, just to see what happens when we use boiling water as opposed to ordinary water. When I say ordinary water, we'll have to use water that has been boiled and cooled down, just so we get the same sort of water, because water out the tap would be slightly different. Okay, so we got 1.58, 1.59, 1.6. Obviously we haven't got a load here, we're just measuring it straight off the strips. Normally you'd have some sort of load involved, but I just want to measure the voltage. Yeah, we could try and measure current as well, but then we would need to put a load on there. Looks like we're going right the way up. I'll go and put some water in the kettle and boil it. Right, that's gone up to 1.7. Seems to have stabilised at 1.7. Right, kettle's boiled. This has actually dropped back to 1.68. It's slowly dropping away. But we'll take these out. I'll tip the water away. Put them back in again. And now we'll put boiling water in there. And the answer is, it looks like it's about the same, doesn't it? That's actually dropping away. It started off the same. This is related to the video I did about my solar rocker that runs off, or was running off, a water battery just like this, that seems to lose power when it's been in a sunny room. When the sun warms the water up, it seems to lose power. And this does seem to be dropping away, doesn't it? Ideally, we'd have two identical cups of water, one cold and one boiling, and compare them to each other. But I'd need 2 meters that I trusted also. Going back up again now. Obviously the water will be cooling down. We'll just leave it for a few seconds. Yeah, maybe a few minutes just to see what happens. That's sort of definitely dropped away, and now it seems to be possibly coming back up again. And that could be as the water's cooling down. It could even be the electrodes themselves being heated up, making a difference. Higher temperature in the metal, higher resistance. That could be it. That seems to be climbing rapidly there now. Yeah, back down again. Teasing me. of course there will be some sort of convection current going on in the water, where the hot and the cold will be changing place. I don't think the camera will pick it up, but there is actually movement on the surface. I could move the camera and see if we can see it. You might be able to see it's like a layer of dust on the surface, swirling around. And that'll be the convection current of the water. Well, we've gone back up to 1.59. Oh, back down again. Let's just put the camera back in the tripod. Yeah, 1.59. So it looks like the voltage is going back up again. 1.6. As the water is cooling down. I have to put this video on my other channel where I put the long boring videos. So I can't really speed this up because I haven't got a clock to show you the time going by. But we've been running for 14 minutes now. And it does look like the voltage is picking up as the water cools. It's still going to be hot. I did have I've got a thermometer somewhere. If I put it in there, that's going to change the temperature anyway, and it's going to stir up the ions just putting it in there. I'm thinking about it. It's an ordinary thermometer, not one for putting in boiling water. I'm going to have a look at it. I'll leave this running. We're up to 1.6 again. I've got this thermometer. Can we? Yeah. All right, we've dropped to 51 degrees. Let's point it at the electrode. 49 on the electrode. 50 on that one. Oh, can't see that. 52 pointing at the water. 53 pointing at the water. So that's cooled significantly, because it should have been 100 when it was freshly boiled. Yeah, all right, well, we're 17 minutes into it now. And we're up over 1.6. Yeah, shame I didn't put a load on it. But we can still see the effect. That it dropped right away when it was freshly boiled. And it's slowly picking up again. And my wife's just asked me to make a cup of tea anyway, so I shall fill the kettle up again and boil some water for our cup of tea. I'll leave this running just to see if that goes up, how far it goes up. Right, it'll get noisy while the kettle boils again, but I'll leave the camera running just so we can see if the voltage goes up any further. Let's add some more boiling water, see if the voltage goes down again. Yeah, dropping away. But like I say, it could be the resistance in the electrodes going up as they heat up. I'm going to call it a day there. We're up to 23 minutes. And I think we've demonstrated voltage drops when we put boiling water in. And just out of interest, it is lighting a red LED. So that's out. On. Off. Yeah. So enough voltage to light a red LED just from copper and magnesium and water, but not enough for a white LED. So we have a red and a white next to each other. Nothing on the white, but the red one lights up. Better just check we haven't got a duff white one. No, that one doesn't light up either. And double check. Wrong way round, Grandad. That way round, yeah. Bit of a difference when we actually put a battery on it. Nothing. It's one of those questions we get occasionally. White LEDs and red LEDs, they are different. You can look up tables if you go on Google and look for LED forward bias voltage, and it'll tell you white are about 3 point something, red are about 1 point something volts. So thanks for watching. Don't forget to like and subscribe. Leave us a comment so I know how I'm doing. And somewhere up here there'll be some links to related playlists. Thanks again.